Hi. Welcome to the 2014 International Space Apps Challenge. Global. Thank you very much. Welcome to the global main stage for the entire event here in New York City. Awesome, thank you. My name is Mike Caprio.
I'm Alice.
Allison. We're representing Startup Bus and the New York Tech Council. We've been co-organizing this event now. This is our third year. This is the third annual Space Apps Challenge in New York City. We're so, thank you. We are so extremely proud and honored to be hosting this event here. And we want to issue a warm welcome to all of our friends from both NASA and Second Muse who are helping make this incredible, historic event happen all across the world this weekend. So without too much further ado, because we're already running pretty late, I'd like to introduce Deborah Diaz, who is the Deputy CIO and Chief Technology Officer at NASA.
Welcome, everyone. Again, we appreciate your spending your Saturday and Sunday here with us. We have a very exciting 65 challenges, and we are, this is a global event in 93 locations around the world, plus one other, which is virtually. I'm getting a signal here. All right. We have lots of challenges. I think you've probably seen them on the website. They're in asteroids, technology, in space, robotics, Earthwatch, and also human spaceflight. So we welcome this mass collaboration and really thank you all for your participation with us. And now what I'd like to do, since again we are running behind, is very quickly introduce my colleague from NASA, our esteemed astronaut Doug Wheelock. He actually was part of the STS-120, the shuttle Discovery. He had a 15-day mission with 3 spacewalks. He also flew and launched the Russian Soyuz. He was on the Soyuz. Spent 6 months on the International Space Station. And then he was the commander for the Expedition 25 with, again, 3 spacewalks. So please welcome Doug Wheelock.
Thank you, guys. All right. Okay, first, the obligatory selfie. Okay, no hand gestures or faces that you won't want to see on Twitter later. Okay, guys. All right. It's going to be a great day. We're going to have fun. If you're not heads down tweeting somebody or putting something on Facebook or developing a new app for this challenge, then you're probably. Wow, was everything okay over there? But welcome. We're gonna have a fun day and just celebrating space. It's actually International Space Day as well today. April 12th was the 1961 was when we launched the first human into space. Yuri Gagarin from the Baikonur Cosmodrome in Kazakhstan. And actually, we still launch, when you see a Soyuz launch with US astronauts and Russian cosmonauts, we still launch from the same launch pad. So it's actually a very, very exciting day, and we're celebrating Yuri's night tonight around the world as well. So without any further ado, I think we have a message from the International Space Station as well. And actually, our commander on board the space station is actually Japanese astronaut Koichi Wakata. And we've got 3 Russian cosmonauts on board, 2 US astronauts, and a Japanese astronaut is the commander. So here we go.
Greetings from the International Space Station. I'm Expedition 39 Commander Koichi Wakata. I want to welcome you to the 3rd Annual International Space Apps Challenge.
Many nations have worked to create this magnificent orbiting laboratory that we live and work in every day. Right now, you are collaborating around the world to develop solutions that could contribute to future space exploration missions and to help improve life on Earth.
Innovative thinking sparks huge advances in human spaceflight. We're so excited about all the work you are are doing at the International Space Apps Challenge.
So keep working hard to help us build our future. We need you to help us see our world differently.
Great. So basically, at this point, we will be starting to do a STEM presentation with Doug in the back room for our students and kids, and everyone else who's arrived, who's an observer or a participant is welcome to attend. We're also going to be doing API demos here on this stage with our sponsors. And we'd just like to take a moment to say thanks to all of our wonderful sponsors who have contributed to making this awesome event happen for all you guys. They've paid for all the great snacks and refreshments and everything you guys are going to have all weekend, and the t-shirts that you guys will be getting. Awesome t-shirts. I'd like to say great thanks to our interstellar sponsor, Amazon Web Services. Thank you very much. They really contributed a great deal to our event, and we're extremely grateful to them. We'd also like to say thank you to Twilio, to TouchLab. There's Kevin right there for TouchLab. Kevin, a great supporter of Space Apps. He's been with us from the beginning as well. And SendGrid and About.com. So again, please say hello to all these guys on social media. Thank them for their help with sponsoring the event today. We will be hearing a few words from each of them in turn. So Doug, we'll bring you into the conference room in the back. And a few more minutes just to get us changed about. And thanks very much.
And we will
Oh, I'm sorry. We're also having a Google Hangout at 12:30? At 12:30. It's a worldwide Google Hangout. Astronauts and folks from all over the world participating. Doug will be doing it from here in the Touch Lab office. So you can tune into that as well, or kind of, we're going to have it secure in the room here, but you'll be able to see that online and join in as well. Thanks very much.
So instead of awkwardly standing on the stage and then driving my laptop, I'm just going to stand here and hopefully everyone can see me. Actually, it's not really so much relevant if you can see me, but as long as you can hear me, it's fine. So my name is Peter Mark Bearward. I'm a solutions architect in the Amazon Web Services New York office. Being a solutions architect means that I get to talk to customers of pretty much any type every day and try to help them understand and explore what's really possible on AWS. So it's a fun job, it's an exciting job, and I get to do cool things like come here and talk to you guys and see what you guys are doing, as well as work with customers like NASA, which one of AWS's customers. They did some really cool stuff with like the Curiosity rover. So that's a lot of fun. But what I'm here to do today is it's called an API demo, but that's not really exciting from our point of view. Our APIs are pretty well documented, and they do kind of a lot of the things you'd expect, and our documentation goes through a lot of it. What I'd really like to do is talk to you guys a little bit about what AWS can do to help you out in the next 2 days to get up and running as quickly as possible with as little effort on your part, and just kind of try to distill down what AWS can do in the simplest way possible as quickly as possible. So here's the platform. It's basically infrastructure building blocks spread across around the world in a number of different sections. But if you were to look at the services we have, it's something like this. That's a lot of stuff. So there's a global footprint. We're in 10 regions around the world. We've got CDN, we've got databases, we've got storage, all sorts of stuff, which may or may not be useful to you over the course of 2 days. So, what do you end up doing? All right, where do you start? I think, I've done a couple of these hackathons. We had our own hackathon last November for the first time. So what we really say, you've got a limited amount of time, keep it simple. What you really need, you need something to run whatever you're going to write. You need a place to store it. You probably need a database. And actually, you very likely will need messaging. So what we're going to do is we're going to skip all the rest of that stuff, and we're going to focus on the core things that we think will be most useful. So starting with servers, if you're not familiar with AWS, the core product is called Elastic Compute Cloud, that's EC2. If you are familiar with AWS, I'm sorry if this is going to be fairly remedial, but I want to cover the basics. So AWS just recently did a whole kind of server family upgrade. It just kind of completed actually just this week. So most of our most recent generation instances, which is what we call our virtual machines, we call them instances, have been upgraded to either Sandy Bridge or Ivy Bridge computers. They're all fairly recent and fairly new, and we've come up with a somewhat logical naming scheme, which is something that we were criticized for a long time. So now it actually kind of makes sense. So there are three families of instance types that I think you should look at. The M3 family is made for general computing. If you're not sure what you need, start with an M3. There's a fairly wide range of sizes, as they are in all these families. And the naming kind of makes sense. A medium is half the size of a large, an extra large is double the size of a large, and so on. And so that's kind of the logic behind the different sizes in each family. So if you're not sure what you need, try an M3. And then once you figure out what's going on, then we have different kinds of families that are tuned in different ways. So the other two that I think you should look at are the compute optimized family. So that's the C3 family. And again, it comes with a bunch of different sizes, extra large, double extra large, all the way up to 8 extra large. And one thing that you'll notice across the board, like an extra large from any family will have very similar stats to what it is in a different family. So that's kind of the idea, to give you a lot of granularity, to pick out what kind of virtual machine you need, what kind of horsepower you need. The final family to look at is the R3 family, which is RAM optimized or memory optimized, depending on if you want to include that little R. It's for RAM optimized, and they have a lot more RAM as compared to, say, compute. So those are the three families to kind of take a look at. There are some other ones. There are intensive SSD storage instances in the I2 family. There's the high storage family, the HS1s. There's GPU-focused families at G2, which may or may not be useful. I think if you have a feeling like you're going to need something like that, there's a good chance you probably already know that anyway. The last one I want to mention is the T1 Micro. It is an extraordinarily small, very, very underpowered instance type. And the reason I bring it up is not because it's underpowered, but because it costs 2 cents an hour. It's really fantastic for testing. Other than the fact that the amount of CPU that you get with it is pretty small, it functions in every other way. It functions the same way with the API. It functions the same way. You can run Linux, you can run Windows on it, whatever you want to do. And so it's an awesome little testing tool. So take advantage of that. So getting started with EC2, you pick an instance size, and then you pick an OS that you want to run on it. We have a bunch of templates. We call them machine images, Amazon machine images. So you'll see AMI sprinkled fairly liberally throughout our documentation. Pick whatever OS you want. We support pretty much every version of Linux, most versions of Windows Server, and then just get cracking on that. Then you're going to choose what kind of security you need on your instance. The firewall rules, we call them security groups. Choose the instance type from those families, and then get started. And all you're doing is paying for it while you're running it. So fairly easy to get started. You can have a Linux instance up and running probably in about a minute or so. Windows takes a little longer because there's some back and forth that needs to happen with the passwords, but that's about it. Storage. So now that you've got a place to do something, you need a place to store something. There are two types of storage services that I think will be useful. Elastic Block Store, EBS, allows you to create virtual disk drives and attach them to your instance. You can create anything from a gig up to a terabyte instance. If you need more than that, then what you do is RAID them together. So you can get a lot of storage on a single instance. If you want really predictable performance, let's say you want to run your own database, or you need a disk system that performs really, really quickly, what you can do is, there are two versions of EBS. There's regular and then provisioned IOPS. You can say, you know what, I need this to be performant at I need 2,000 IOPS, I need 4,000 IOPS, whatever it is, you can do that on EBS. The other storage service you're going to use, simple storage service, S3, is object storage. It's not meant for a file system. It's over an HTTP endpoint, so it's too slow for a file system, but it's really great for storing static assets. If you want to launch a website, throw JavaScript, CSS, HTML up there. serves it out like a dream. It's really super fast, very, very durable, pretty easy to use. And actually, one last note, and hopefully I'll have time for this, you can actually host a static website on S3. So you can actually have, if it's all client-side code, all JavaScript, stuff like that, you can actually host it there. Databases. So there are a few database options. The easiest one, if you're starting off with SQL, relational database service, it's managed, MySQL, Postgres, SQL Server, Oracle. It's pretty easy to get started. A lot of the same instance type options as in EC2. There's also Elasticache, the same idea, except it's managed Memcache or Redis. Now, these two I probably wouldn't include for a regular hackathon, but given the state of the amount of data that NASA has, it might come in handy. The first one is DynamoDB. That's our managed NoSQL database. Really, really easy to get started, and capacity's, for all intents and purposes, unlimited. And like EBS, you can set the level of performance that you want from it. The other one, again, I would really almost never bring this up at a hackathon, but again, size of the data. So Redshift is a data warehouse, so it's basically a columnar store, and it's really easy to store huge amounts of data and get really responsive times out of that. Messaging. So this was the last of the 4 categories that I said that might be necessary. Now the thing about these services is they don't sound really core, they don't sound really essential, but actually they're really, really handy at making kind of distributed tools that are resilient and kind of can stand up to a lot of kind of pressure and data and activity and so on. So take a look at them because they're going to help out setting up applications that can be run independently and be developed independently as well. So the first one is SQS, Simple Queue Service. Lets you send in messages. I mean, the name really describes it extremely well. It's just text messages that are reliable and distributed across our various data centers, so you don't have to worry about building out your own messaging queue and so on. Same thing for a simple notification service. It's an easy way to send out notifications, pub/sub. You can send them out over text messages, emails, or HTML endpoints. So it's a really easy way for different components of an application to send out messages to other ones. And then finally, simple email service. If you guys end up having to send out email, SES is basically its goal is 2 things: to send out reliable email, to send it out in massive quantities. If you've ever gotten email from Amazon.com for anything at all, it came from SES. So their focus is sending out really, really very reliable email and in huge volume. So if you have any kind of need of that, SES is your ticket. So now that those are the basics, if you have any more questions about like finer details about where exactly do all these things sit, whether you should be standing up resources in Virginia, Oregon, or Singapore, whatever, come talk to me afterwards. But those are kind of the basics, high-level overview. So if you want to actually use this stuff, there are a few ways. So there's the console, which looks a little daunting, but really if you start looking at only the things you care about, you can ignore the rest. There's command line tools, which are available for Mac, Linux, and PowerShell on Windows, so pretty much every platform. They integrate with every single service. It's fairly intuitive to use. It was recently upgraded about a year ago, so it started. It really started to grow since then, and now it's actually fairly mature and it's fairly natural to use. It kind of works the way you think it should work. We have SDKs for pretty much every popular language. Should be able to figure out something that you like. One of the new ones that I'd want to point out, and I'm actually hopefully going to demo, is a SDK for JavaScript in the browser. And so you can actually call AWS resources client-side, which enables you to do some kind of cool things. There's also plugins for Eclipse and Visual Studio. And finally, one thing that actually we developed here out of the New York office is this thing called Developer Quick Start. So the bit.ly link is bit.ly/AWS DQS. And it's just a way to quickly spin up a developer stack. It spins up a Git environment, Jenkins, and a sample project in one of Ruby, PHP, or Java. So if that's your language of choice, it'll just put in stubs. You start developing out your environment. You start developing out your own application, and you've got kind of a development environment already going. All right, so just a few quick demos. So if, oh my, that is small. So, wow. That is small. All right, so here's the here's the console. There's obviously a lot more to it than just what fits on the screen. What I'm going to do is actually go to Elastic Beanstalk. So Elastic Beanstalk is a service that kind of fully manages a lot of this for you. What you end up doing is uploading an application to Beanstalk, and it deploys servers. It takes care of putting a load balancer on it and scaling it and so on. And so it's actually a really easy way to deploy an application. So what I'd like to do is just kind of show that off right now. So I'm going to pick an example application. What I could do instead of doing this is actually upload an application, but I'm not going to do that. I'm just going to launch a PHP application. Literally, that's all they're asking me to do. There's nothing else for the sample application. If you were to upload your own application, all you would do is say if it was PHP, here's my zip file of my PHP project, upload it, and there it goes. So I'm not going to wait for that to launch. I'm going to do the whole cooking show thing and show you what it looks like when it's done. There's a bunch of information about when it launched. There's some configuration details that I can change around, like how much scaling it is, what kind of instance type I want, some PHP specific changes that I can make, and so on. But if I want to check out just what it looks like, this is literally, I did nothing to get this launched, and I have a PHP application that's up and running right now because of Beanstalk. So if you want something that deploys very quickly, very easily, and you don't actually care what's running on the back end, Beanstalk's a great way to get started. The last thing I wanted to show you was just that the browser side demo. So everything I'm about to show you is actually only running on S3 and using DynamoDB as a backend. I'm actually using no servers for this at all. So I'm going to log in with Amazon. And then it's a really simple demo. This is in D3. It just shows, it's doing an aggregate counter of everyone who's logged in and seeing what browser they have. So this is obviously very, very simple, but it's also using no servers at all. It's being hosted on S3 and using Dynamo as a backend. So there's a lot of potential there if you really want to avoid all that. If you can pull it off that you can do it all server side, all with JavaScript, there's a lot of potential there. All right, so that's it. If you have any questions, you can ask me or some of my colleagues who are going to be filtering in and out over the course of the weekend. I'm not sure if it's happened yet, but you should all be getting credits for AWS. So it's usually, I think it's going to be $100, which should be more than enough to take you through the weekend. And what else? Oh, finally. Once you stop using something, shut it down. It will continue to bill if you're not using it. So really very important. Don't forget that. Whether it's at the end of the night, whether it's the end of tomorrow, please shut it down after you're done. And see me if you have any questions, and happy hacking. Thank you.
Next, we'll be welcoming Ricky Robinette from Twilio, developer evangelist, startup bus member, and all-around awesome guy. Also, if anyone's interested, the presentation with Doug was delayed a little bit, so we'll be starting in just a few minutes. I know everyone wants to see the API demos, but everyone will also be here to help you and give you additional, like our API guys will stick around this weekend if you need any additional help. So if you don't want to miss Doug's Q&A and presentation stuff, now's the time to head back over. Not to steal your thunder, Ricky.
Yeah, like, how am I going to compete with an astronaut?
There you go. Thanks very much.
Well, thank you to the people that chose me over the astronaut. That's like, I mean, I feel like I'm going to like write my mom an email and be like, all these people wanted to listen to me talk. I'm Ricky. I'm a developer evangelist for a company called Twilio. Twilio makes it easy for developers to write code that sends and receives text messages and makes and receives phone calls. So you may be asking how that works, and I have this great image, but the resolution is maybe going to mess it up. Here we go. So basically, a user, calls a phone number or sends a text in. It goes into the Twilio cloud. People love the word cloud. And we say, oh, this is for your app, and we ask your app for a basic set of instructions of what to do with that call or text message. But I could sit up here for like a few minutes and tell you how it works, but it would be a lot more fun to just build an app together. So we're going to do that. Kunal, would you mind being my mic stand? I'm not going to try to one-hand code this because that would take like 2 hours. It would not be fun. So Kunal has volunteered. It's my pleasure. So the first thing we need to do is get a phone number. Normally I ask like, what area code do people like? But we're in New York and there's only one area code that matters in New York. That is 718 Brooklyn. Represent. So I am going to buy a 718 number. This one looks great, even though I can't entirely see it. Oh, it's beautiful. Congratulations, we just bought a phone number together. It's a boy. I thought that was a good one. It's like a baby, but it's a phone number. You guys really wish you went to see the astronaut, don't you? So basically, when you set up a Twilio app, as I mentioned, we need a basic set of instructions of what to do. And the first thing you do is tell us where to find that basic set of instructions. So you can do that for voice or messaging. We're going to build a text messaging app. So I'm just going to give it a URL on my server. I'm going to save this, and then I'm going to hop into terminal where I'm much more comfortable. So we need to write this set of instructions. So we said message.php was what I set it to. And I'm going to use Vim. All right, do we have any Vim fans in the house? Oh, wow, a few. Last time I got booed when I said like, oh, I'm going to hop in Vim, and like people were like, boo, Vim, Emacs. So I'm going to write message.php. So the first thing I'm going to do is say that this is XML. So we use something called Twiml. It's our own version of XML that's just really basic to know what we should do. So I'm just going to say header, content type, text, XML. And then I'm going to give the instructions. So the first thing we do is set a response. We are sending a request to your server. You need to say we're going to respond. So I'm going to have a response tag, and then I want to respond with a message. And I'm just going to say space because space is awesome. And then I'm going to give you my email, ricky@twilio.com, or my Twitter @RickyRobinette, if I can see it. There we go. I'm going to close this tag. And now this is where I need your help. If you have a cell phone, can you get it out and turn the ringer on and turn it up all the way? And once you've done that, send a text message to this 718 number. And assuming I didn't have any bugs in my code, which is not a promise, you will get a response with that message I wrote. So the number is 718-701-8642. 718-701-8642. And if you get a response, can you just give like a whoop whoop? Oh, awesome. So we did that for a text message. We can do something similar for voice. So it's the same type of file. Oh, that was good. So if we wanted to do a voice call, we could do something like, oh, that's so good. You guys are really enthusiastic. Sometimes I tell people like make a woo, and then they're like woo. So you guys are awesome. So I'm gonna have a robotic voice say space again because space is awesome. But I have this audio track that I want to play everyone. It's really, really cool. I don't want you to know what it is, but I'm gonna use the play tag, and then I'm gonna point it at this MP3 on my server, which is .mp3. So I built this Twiml file for voice, and I could plug this in on the console we saw before, and if everyone called in, they would hear the robot say space, and then they would hear the audio file. But it seems like it would be a lot more fun to just call everyone in the room, so we're going to do that instead. So I'm going to save out this file. I'm going to hop in Python. Oh, Python fans! I used to do this in Node, and I got booed when I did Node too. So I figured I can only get booed once, so I picked Vim and Python, because people like Python.
Go Ruby!
No, Ruby, wow. So the first thing we're going to do is import a little helper library to use with Twilio. And then I'm going to instantiate it. Normally you instantiate this with some keys you get from our app. I have these saved on my server so you guys don't steal my identity. And then I want to get every message people send in. So I'm going to say client.message. I'm going to get an iterator of messages to this 718 number. So this is always fun because what we're going to do is we're going to display all of these on the screen. So normally people send in something fun, we'll see. So I'm going to say for message and messages, loop over all of these. I'm going to print message.body. And then I'm also going to call everyone. So I can say client.calls.create. I want to call to the person who texted in. So that's all of you that sent a text in. I want it to be from our wonderful Brooklyn number. And then lastly, I want to give it the basic set of instructions. So that TWIML I wrote earlier, which is on my server at demo.rickyrobinette.com/voice.php. And then, assuming I don't have any bugs in my code, we're going to have two things happen here. One is we're going to see what everyone said, which is hopefully has something hilarious in there. And then you're going to get a call. Feel free to answer and put it on speakerphone when you get the call. Oh no! So from is a reserved word in Python, obviously, and so we have from underscore, and I missed an underscore. There we go. Let's try this again. Pretty cool stuff. So if you start getting calls, feel free to. Oh, somebody sent a rocket in. That was cool. Yeah, so feel free to answer, put it on speakerphone if you want. Nice. So if you don't recognize that beautiful opening, you've just all been rickrolled with Twilio. I'm Ricky Robinette. I'll be here most of the weekend when I'm not at a wedding. Fortunately, not my wedding. I'd be in big trouble. Feel free to come ask me any questions. I can hook you up with some Twilio promo code too if you come find me. Thanks a lot.
No, I was just out there. Back in their co-working space. Yeah. It's been a while. Yeah.
Space. How's it going, guys? My name is Kunal Batra. I'm a developer evangelist at SendGrid. And I'm going to keep this short and sweet because I know you guys want to hack. So SendGrid is an email API. We make it really quick and simple to send and receive emails from your apps. So if you ever got emails from Pinterest, Foursquare, Spotify, Uber, those emails go through us. And we use the best practices to make sure your email gets delivered. We also give you awesome analytics so you know who's opening up your email, when they're opening it up, and from where they're opening it up. And instead of talking a little bit more about SendGrid, I just want to show you a really cool example. So I made this app on the way here, and basically this takes advantage of our inbound API to showcase what we can do. So if you guys can, take out your phones and send an email to change@color.gd, and the subject, put it any color. It looks like people already started. So what's going on right now is that email is going to that domain, and in the SendGrid backend, we have to point it to some application. And then from there, this is built on Node. Someone tried to troll me, made it all black. You can still see the domain. But yeah, so then from here, I'm just sending that color to the front end and changing this, the color of the background. And this is all happening through our Parse API. Nice. Very cool. Yeah, so that's the advantage you can take with SendGrid. You can kind of send outgoing emails and get incoming emails to your application. So for the hackathon, for the best use of SendGrid, we're going to give away 4 tickets to the Intrepid Museum. So if you guys want to add a little email goodness into your apps this weekend, definitely go to hack.sendgrid.com. That is hack.sendgrid.com. Oops, I went there anyway. Okay, and it's free. It's totally free. So make an account at hack.sendgrid.com and tweet at SendGrid or find myself and to get your account provisioned. And that just means we make sure you guys aren't spammers. And good luck hacking. Thanks, guys.